Chapter 4 deals with numerical data, quantitative data, how to display it, how to summarize it. The summary statistics are mean, median, mode. Mode's not really used that often, except for as a description of shape. We look at the distribution of quantitative variables. It slices them up into all the possible values of the variable into equal width bins. The most common distribution is called a histogram, which looks like a bar chart, but it's the bars are touching, and the x-axis is numerical, so it's continuous. A distribution is considered uniform if it's roughly flat. So it might look like this with the bars all really close to the same height. That would be a uniform distribution. Unimodal is when it has one mode. Now again, mode is the value that occurs most often, and so in a distribution, you're gonna have one peak if it's unimodal. Bimodal has two peaks. There's definitely a distinct valley. What is not unimodal or bimodal is if I have two peaks like this, or three, this would be considered one peak. So that would be unimodal here. But if the peaks of my graph drop and then it comes back and peaks again, that would be considered bimodal. So just because there's two values that peak around the same time doesn't make it bimodal unless those peaks are separated. A distribution is symmetrical if the two halves on either side of the center look approximately like mirror images of each other. Symmetric, we generally mound shaped. Symmetric can look like this. Could also look like this, where you have a line of symmetry. Okay. What is it? Sine and cosine? A distribution is skewed if it's not symmetrical and one tail stretches farther than the other. The skew, the direction of the skew is the direction of the tail, not the majority of the data. So a skewed left distribution, left is, hold on, skewed left might look like this, where the tail stretches to smaller numbers. So you have a mound at, you have the most of the data over here, but there's some outliers possibly and a bit of data that trails off to smaller numbers. So skewed to the left has a tail that goes to the left, and skewed to the right has the tail that goes to the right. The majority of the data is in the smaller numbers, and it trails off into higher numbers. These are descriptions of shape. Wow. Stop. I keep hitting that button. Okay, symmetric and skew is are descriptions of a graph's shape. So is whether it's unimodal or bimodal or uniform. Okay, those are both descriptions of shape. When we describe a distribution, we're going to talk about the shape, the center, and the spread. So you're going to say whether it's unimodal, bimodal, and you're going to say whether it's symmetric or skewed left or right. Okay. Outliers are extreme values that don't appear to belong to the rest of the data. These might be unusual values that need further investigation, or they could be mistakes.
There are times when you are putting the data into the calculator and then drawing a graph, and you graph it, and you get this data point that's way out here, and it doesn't make sense. A lot of times it's a type error. You've typed in 3 digits for a number that's only 2 digits, so all your data is centered around 50, but then you have a data value that's over at 550 because you accidentally typed an extra 0 or an extra 5. So it's important when you see outliers to make sure first that your data was entered correctly, and then sometimes we need to investigate, that isn't a mistake. What can we say about that outlier? We want to look at it. We want to investigate it. We want to say, okay, I'm looking at shoe size. Okay, well, 23 shoe sizes, Shaq's shoe size, that's an outlier in most graphs, right? He has an unusually large foot. Sometimes you remove the outlier and continue with your calculations. Other times you have to keep it in, okay? Questions? Okay, so again, when we describe a distribution, we talk about the shape, the center, the spread, and the outliers. We use an acronym to help us remind us, and that acronym is SOX. If you're asked to describe a distribution, you want to talk about the SOX: the shape, the outliers, the center, and the spread. Okay, so we have shape. You talk about whether it's unimodal or bimodal. Does it have 1 or 2 peaks, or does it have lots of peaks? The center, we want to calculate the mean or the median if we have the data. If we're just looking at a graph, we want to figure out where we think the graph is going to balance, kind of like a seesaw, right? Where would the center of that seesaw be to balance that graph on it? So we can approximate it if we don't have the data, but most of the time you need to calculate center, and those measures of center are mean and median. Median is what? The middle number, right? The mean is what we get when we add it all up and divide by how many there are. That's the average. The median is when you put all the data values in order and you find the middle number, okay? The spread, how spread out are the values? Measures of spread are range. Range is the max minus the min. Range is max minus min. Okay, the biggest mistake students make when they talk about range is they say the range is from 1 to 10. No. If the data goes from 1 to 10, the range is 9. We subtract them. It's a single value. Okay. IQR. The IQR stands for the interquartile range. We'll talk about that a little more in a minute. Okay, which is the Q3 minus the Q1, quartile 3 minus quartile 1, also a single value. Okay. And standard deviation is a super fun calculation that we're going to do a little bit of today or sometime this week, and then we'll let the calculator do it for us the rest of the time. Okay? But it's important to understand the idea of what standard deviation is and how it's calculated so we can better interpret it. Outliers are any values that seem unusual. For this chapter, outliers are a judgment call. Yes, this value seems like it's really far from the rest of the data. No, it doesn't seem like there is any. In the next chapter, and when we get into the normal model, the idea of outlier will be more of a calculation. And it'll be more like, yes, it's an outlier. It's past this value. Okay? So again, shape, outliers, center, and spread. Okay, you want to talk about these 4 things when you are asked to describe a distribution. And if there's no outliers, you need to say there are no outliers or no apparent outliers, not just not mention it. Okay? Questions? So before I had children, I used to play video games a lot, and then I had children. You have no time for video games because you find yourself sending them back for a longer nap so you can play longer, and then you realize, I'm not being a really good parent. So, I played the game Portal, and of course, me being a math teacher, I was like, oh, look at this leaderboard. I'm going to take a picture of this to show how distributions actually show up in real life. So, has anybody played Portal? So it's this game where you have a gun, okay? And the gun shoots a portal in a wall, and then you walk through it and you come out somewhere else on the other side. So you have to shoot, like if I want to come through here and come out on that side, I shoot one portal there and another. And you have to basically get out of the room, right? So there might be like lava on the floor or whatever, and you have to find your way out of the room. And of course it starts out really easy, and then it gets really hard towards the end of the game, like every video game possible. So it's kind of like a problem-solving type game, and sometimes you have to like put the best one you had to put a portal in the roof and then into the ground, and then you have to jump through and let yourself fall and start to gain speed, and then while you were falling, you had to shoot another one so that when you fell through the bottom, you'd have speed to come out of the other portal and like launch yourself around the room. It's actually a really fun game. You should look it up. But anyways, okay, that's beside the point. The point is they have community statistics here that are showing you how long it took people to get out of this room. Okay, this is a distribution of the time it took. This graph has a skew to the right. We can see these values here. And then all the way over here, okay, this person was probably AFC, away from console, because there's no way it actually took you 40 minutes to get it out of the first room, okay? So this would be considered what? An outlier. Here we have an outlier, okay? So this data you could describe as unimodal because there is one peak. This data is skewed to the right because the tail is to the right. Yes, Caleb?
And the range would be 40.
Yes. So our center, though, center is a judgment call here. It's probably around in here, 1 or 2 minutes, right? So if that was labeled, if this is 40, that makes this about 20, this about 10. So the center is around, let's say 1 to 2 minutes. Okay. The spread, well, hold on, the range of 40 and at least one outlier. Okay, that's how you're going to describe a distribution like this. Okay, the shape, the center. You don't have to say the spread is a range of 40. You could just say, if you say the range is 40, well, we know you're talking about spread. If you say the mean is 2, then we know you're talking about center. You don't have to say the center is mean of that, right? Okay. Here's a couple more. This one's a little more interesting. This one had a lot more variability is the word for how it's more spread out. Okay, there's a lot more changes going on. We would call this graph maybe bimodal. There's 2 clear peaks here. There's a peak here and a peak here. Okay. There's also a peak here at the end.
Trimodal?
Could be trimodal, multimodal. Okay, so we can say this is, we'll call it trimodal. Which direction, what is this, is it symmetric, skewed right, skewed left? Skewed right. Where do you think the center is?
24-ish?
Yeah, it's probably somewhere in here, about 20, maybe a little bit less. Okay, think about how you're averaging the higher numbers in, so it's not going to be at the main peak, but the center is probably around 20. There's a lot of leeway if you don't actually have the data and can calculate it. Okay, so if you said anywhere between 20 and 30 or 15 and 30, you're fine in your estimation of the center. Okay. Now the lowest point here is maybe about 5, so what would you say the range is? Range of 35, 40 minus 5, whatever that estimation is. Again, there's no labels on this graph from here to here. If we're giving you a graph with no labels like that, we expect a lot of differences in how you estimate where those points are, and that's okay. Okay, so it's okay if you said 35, but someone else said this is about 3, and so they said 37. It's okay. Okay? And then do you think there's outliers?
Yeah, beginning.
Maybe this one's an outlier, right? So one, or possible outliers. It's okay to just say possible outliers. Okay.
Now we looked at a dot plot today where we placed one sticker for each person and the number of the siblings they had. That looked like this when we made it in class. Each data point, each sticker represents one person and how many siblings they have. So a dot plot for each value, we place one dot above that number. It's the fastest way to make a distribution of quantitative variables. This particular graph would be considered unimodal. Again, I have 2 peaks at 1 and 2, but they're equal. So that's considered as one mode. So this is unimodal. It's skewed to the right because my tail is over here on the right. With the center at 2. We calculated the median. We had 35 kids in class today. So that means the median was the 17th value. And so we counted 17 and it was somewhere here in 2. The range is 6. Remember, the range isn't from 0 to 6. It's that subtraction from 6 to 0. And there's possible outliers, but we don't see too much separation. So we're going to say possible outliers. Later on in chapter 5, we're going to get a specific calculation for outliers.